Hello everyone, welcome back to this tutorials again. So this is lecture number 5 on module number 1. So module number 1 is little bit lengthy, so other modules takes little bit less time, but module number 1 takes little bit more time, so it takes more number of lectures. Okay, anyway, uh, in previous session we have discussed about basic relation between properties of the soil. So in that, relation between porosity and void ratio we have found out. So this is a formula which we have arrived at the end. So similarly, relation between E small w, E is water content, small w, sorry, E is void ratio, small w is water content, capital G is specific gravity, and degree of saturation is S. So relation between E small w, G and S we have found out, and finally we have arrived at this particular equation. Further, you can see even we have studied about the basic relation between mu d means unit weight or bulk unit weight I can call. So if I say generally as a unit weight, you have to just think it as a bulk unit weight, and dry unit weight, this is mu d, and water content, that is small w. So a relation between these three also we have studied. Further, you can see in this relation we have arrived at a particular equation wherein we have converted that particular equation to uh, equivalent other equations also. Further, in previous session we have studied about the relation between mu, specific gravity G, void ratio E, and degree of saturation S. So we have arrived at this particular equation: mu is equal to mu W into S into E plus G divided by 1 plus E. So this equation can be converted further, and based on this equation and the degree of saturation we have arrived to some other equations also. So you can see mu is equal to mu W into S into E plus G divided by 1 plus E. In this degree of saturation plays very important role. How it plays very important role you can see over here. If the soil is fully saturated, or if the soil S value is equal to 1, you can see that this general unit weight will be converted to saturated unit weight, and this saturated unit weight will be equal to mu W into G plus E divided by 1 plus E, because S is equal to 1. So same equation I have used and I have converted. Further, if the soil is fully dry, so there are two cases: when S is equal to 1 and when S is equal to 0. What is S? S is degree of saturation. So when S is equal to 0, this entire term vanishes. So what is remaining when S is equal to 0 means degree of saturation is equal to 0. Unit weight will be converted to dry unit weight, because if there is no weight of water, then the total weight will be equal to weight of dry soil or weight of soil solids. That's why the regular unit weight will be converted to dry unit weight. So for that we have arrived at this particular formula. So today you can see we are going to study about few more relations, and then we are going to move to the problem. So relation between percentage air voids, that is Na, dry unit weight, that is mu d, water content, that is small w, and specific gravity, that is capital G. So by definition you can see percentage air voids is equal to volume of air divided by total volume, and we know that total volume is equal to volume of air plus volume of water plus volume of soil solids. So you can see dividing both the sides, left hand side and right hand side, by total volume V, we are going to get it as, you can see, V divided by V, VA divided by V, VW divided by V, VS divided by V. So you can see V and V on left hand side are going to get cancelled, so it will be equal to 1. So which is equal to VA by V is equal to, you can see over here, it is nothing but percentage air voids, so that is Na. So Vw by V, Vs by V, I am going to keep as it is. So this percentage of air voids, that is Na, I am going to keep, I am going to take on left hand side, so it will become minus. So further you can see we know that mu W, unit weight of water, is equal to weight of water divided by volume of water. So I am just going to convert it. So in place of uh, volume of water, so in place of volume of water, I can keep it as weight of water divided by unit weight of water. So in place of volume of water, so you can see in place of this, I am going to keep this particular term. Okay, so what I'm doing here, in place of volume of water, I am keeping weight of water divided by unit weight of water. So I have just replaced it. So here I have kept, and V remain as it is. So this is a V which remain as it is. Similarly, in place of volume of soil solids, I am going to keep PS divided by mu S. So how I have taken it, it is given over here. You can just go through it. So finally I have arrived at this particular equation. So you can see here one very interesting thing you can observe here is weight of water is equal to small w, that is percentage, sorry, water content into weight of soil solids. So how I came to this equation, so instead of this I am replacing these two terms. So how I came to this equation, you can see, so this is small w, so water content is equal to weight of water divided by weight of soil solids. So weight of soil solids is equal to weight of water into water content. So weight of water into water content. So I am arriving at this equation here. So I have just replaced it. After that, you can observe very important thing over here is weight of soil solids divided by volume is going to give us the dry unit weight. So I have replaced weight of soil solids divided by volume with dry unit weight. So, and I have arrived at this particular equation. Similarly here, weight of soil solids divided by uh, weight of soil solids divided by total volume. Similarly, I have replaced it with a dry unit weight. Okay, so now I'm going to move further. Instead, so you can see over here another thing. So instead of mu s, what I am going to do here is, I know that G is equal to mu s divided by mu w. So mu s, instead of mu s, I am going to substitute G into mu w over here, and finally I am going to arrive at this particular equation 1 minus Na. So this 1 minus Na I am going to keep as it is. So mu d divided by mu w I am going to take outside. So if I take this as a common, I am going to arrive at this equation. So after simplifying and rearranging, the final equation for mu d is equal to 1 minus Na into G into mu w divided by 1 plus small w into G. Okay, so this is the final equation. After rearranging, I am going to get. Similarly, you can see further there are some 3 to 4 relations which I have derived. So these are some important and basic relations. You can just go through it. If you are having any doubts, you can raise the query. But these relations are very much simple. I am not going to waste much time in explaining these relations further. So I'll move forward with the problems. So we'll move forward to the problems. So you can see over here, as I have said, I have made the list of sorry for the disturbance, basic relation between primary terms. So whatever the relations which we have derived, I have did the basic relation between those two derivations which whatever we have did. So those all the formulas I have listed out over here. So list of formulas you are going to get in the notes. So these are the list of formulas. Remember, these formulas you must be very much thorough with, because while solving the problems, these formulas are very much useful. Okay, anyway, I will directly jump to problem number 3, and then we will come back to problem number 1. So as the problem number 1 I have taken from some competitive exams, let us study simple examples first, and then we will move to competitive exam problems. You can see this problem, a dry soil, remember I have underlined a dry soil, has a wide ratio of 0.65 and specific gravity is 2.8. find its unit weight, full stop. Water is added to sample so that its degree of saturation is 55% without any change in void ratio. Determine the water content and unit weight when the degree of saturation is 50% and 100%. Actually, there are two cases in this particular problem. So what are the data they have given? They have given E is equal to, so you can see here, void ratio is equal to 0.65, specific gravity G is equal to 2.8, mu W is equal to 9.8 kilonewton per meter cube. So this is standard. If any value is not given, you need to assume this value of mu W. So what we need to find the unit weight. Actually, they said it as a unit weight. So generally, whenever they say it as a unit weight, just as a unit weight, we need to consider it as a bulk unit weight. But another condition also they have mentioned, as the soil is dry. So when the soil is dry, regular unit weight will be nothing but dry unit weight, because soil is dry. So in first case, we need to find out mu D, and in second case, by using degree of saturation 55%, 90% and 100%, we need to find out water content and bulk unit weight. So here you can see this dry unit weight will not remain over here because water is added. So they have given water is added. So as we add the water, degree of saturation increases. So for this all three degree of saturations, we need to find out water content and bulk density, bulk unit weight. So first case, we need to find out dry unit weight. So dry unit weight, you can see here by using this list of formulas. If I want to find out dry unit weight, so you can go through those list of formulas. I will attach this entire PDF with the notes. So dry unit weight, we are having formula G into mu W divided by 1 plus E. So you might be wondering how I have chosen this formula. So choosing the formula among available formula is very important, because the formula we have to choose such a way that it should fit with all the available data. It should fit with all the available data. So now you can observe one thing. I have E, I have G, I have mu W. So if I move to list of formulas, just go back. So I have several formulas to find out dry unit weight of the soil. So to find out dry unit weight of the soil, I have this formula 1. I have this formula also 2. There are various formulas. So how I have to choose the formula, you can see. So I have G, that is specific gravity they have given. I have E, so void ratio they have given. I have mu W, I can assume it. So I can choose this formula to calculate mu D. If I choose this particular formula, you won't be able to fill up the data which is necessary. So I am not going to choose this formula, I am going to choose this formula. So choosing the formula is very important in these cases. Okay, anyway, I will move back to the problems. So after substituting these values, you can see G is equal to 2.8, mu W is equal to 9.8. 1 I am going to keep as it is, void ratio is equal to 0.65. So mu D is equal to 16.63, remember the unit, kilonewton per meter cube. Now I am going to move to second case. I need to find out water content and bulk unit weight when the degree of saturation is 55%, when the degree of saturation is 90%, and when the degree of saturation is 100%. So in that I am going to take first case, that is when S is equal to 55%. So when S is equal to 55%, I can say that water content I need to find out. Why I need to find out water content? Again, choosing the formula comes into picture. So you can see I have the relation that dry unit weight is equal to bulk unit weight divided by 1 plus water content. So I have the formula. So based on that formula, I am going to arrive to this modified equation. Actually, the formula is like this: dry unit weight is equal to bulk unit weight divided by 1 plus water content. It is there. So if I have dry unit weight, I can use this dry unit weight and water content, I can use this formula. So to use this formula, I need to find out water content. So how to find out water content? I have a basic relation between E, S and G. So E they have given, they specifically mentioned that without any changing in void ratio. So for all these cases I need to consider E is equal to 0.65. If they tell that void ratio is going to change, again I need to calculate void ratio. So they have not said it. As the void ratio is remaining same, I am going to calculate these things further. So water content is equal to E into S divided by G. So E is equal to 0.65, S is equal to degree of saturation, that is 55%. Always remember, while substituting in the formulas you need to substitute with the fractions. So 55% I have converted to 0.55. So divided by water specific gravity they have given, that is 2.8. So finally I am going to arrive to water content equation as 12.77%. Okay, so by using this formula I am going to calculate bulk unit weight. So after substituting all the data which is available, that is 18.75 kilonewton per meter cube, I am going to arrive at the answer. So remember, dry unit weight for a particular type of soil will never change. Okay, so similarly I am going to calculate for 90% of the uh, degree of saturation. So same way I am going to calculate water content, and by same way I am going to calculate bulk unit weight. Similarly, when degree of saturation is 100%, I am going to calculate in the same manner. Okay, so you can go through this problem. If you have any doubts, you can raise your queries. You can contact me. Further, I will move to the first example, so which was little bit complicated. That's why I have directly moved to third example. So which is from uh, competitive exams. So you can see this. The natural soil has a bulk density. Remember, they have given it as a bulk density and water content of 8%. Calculate the amount of water required per cubic meter to raise the water content to 18%. Actually, there is a water content 8%. We need to raise the water content to 18%. What will be the degree of saturation at this water content? Assume void ratio to be constant, so void ratio will not change, and G is equal to 2.7. You can observe one thing over here. Uh, what they said is, they said that already there is a 8% of water content. Amount of water we have to add such that water content should be raised to 18%. So what will be the degree of saturation at this water content? So bulk unit weight is equal to 18 kilonewton per meter cube, which they have given. So it is given over here. So initial water content means water content which is already present is 8%, that is 0.08. Further, G is equal to 2.7. So mu W is 9.8, which is constant. Always it will be same if unless they have specified any other data. So what we need to find out? We need to find out firstly amount of water to raise the water content to 18%. So how we are going to find it? First we need to calculate amount of water which is present in the particular soil. So after that we can calculate how much amount of water we need to add to rise to 18% of water content. So we know that mu d is equal to mu b divided by 1 plus small w. So that is equal to mu b is nothing but bulk unit weight. So just I am going to calculate a dry unit weight. So why I am calculating dry unit weight, you will understand further. So remember, in given data I have not written volume. Total volume is equal to 1 meter cube we have to take. So it is unity they have given. So after calculating dry unit weight by using this formula, initially I have taken water content as a 8%, just as it is an initial condition. At this 8% water content only, bulk unit weight they have calculated. So I need to take it as a 8% initially. They have also given it. Okay. Anyway, further you can say this. So 8% I have taken and I have calculated dry unit weight. With this dry unit weight, I know that weight of soil solids divided by total volume. So dry unit weight, I have arrived at the answer of 16.67, so which is equal to Ws divided by 1. So weight of soil solids in 1 meter cube volume is 16.667 kilonewton. So we know that 8% water content is already present, means water content is equal to weight of water divided by weight of soil solids. So now you might be understanding why I have calculated weight of soil solids. So weight of soil solids I have calculated to calculate the weight of water which is already present. Weight of water which is already present. So now weight of water which is already present I am going to calculate by using this equation, that is 8% water content is there. Weight of water I am going to find out. Weight of soil solids in 1 meter cube volume is given here. So I have substituted this and I have arrived at this equation, that is weight of water 1.333 kilonewton. Already this much of water is present. Already this much of water is present in the soil. So what I have to do, I need to raise the water content to 18%. I need to raise the water content to 18%. So what I am going to do, instead of 8 I am going to substitute 18 and I am going to find out how much amount of water is required. So 18 to rise the water content to 18%, 3 kilonewton water is required. But remember how much of what they have asked, already 8% water content is there. How much amount of water water is to be added to rise the water content to 18%. So calculate the amount of water to be added or to be required to rise the water content to 18%, they have asked. So to rise the water content from 0 to 8 I need to add 1.33 kilonewton, but already this 1.33 kilonewton water is present in the soil. So to rise the water content from 0 to 18% I need to add 3 kilonewton of water, but already 8% of water is present. So from 8% to 18%, just I will repeat it. You need to understand it very carefully because it is very important. So to rise from 0 to 8, I have to add 1.33 kilonewton. So to rise the water content from 0 to 18, I need to add 3 kilonewton. 0 to 8, 1.33, 0 to 18, 3 kilonewton. But already 8% water content is there, means already 1.33 kilonewton water is there. Additional water I have to add to rise it to 18%. So 3 minus 1.33 kilonewton, 1.67 kilonewton water is to be added. That is nothing but 167 liters of water is to be added. So this is the additional amount of water. Further, they have asked what is the degree of saturation at this particular water content. So it is very simple. We have that relation mu into G is equal to U into S. So based on this relation, we are going to calculate a degree of saturation. So at this water content, degree of saturation is 82.8%. Okay, you can just go through this particular problem. It is little bit trickier one and it is from competitive exams, so you can just go through it. Further you can see in next session we are going to solve little more problems on basics as well as few more problems on competitive exams, so which are from competitive exams. So make sure that while attending next class you must be thorough with the formula, or else take the printout of list of the formulas. I will attach the list of formulas. I will provide the list of formulas in Google Classroom. Okay, so see you in the next session. Thank you.